All right, let's take a look now at dealing with finding zeros of linear functions by solving algebraically. This is a lot quicker than solving this with a graph. So if you look at the function I have here, yeah, I could say, okay, I'm gonna, draw myself a graph here, do this, and I'll figure out, okay, I'll put in some numbers, but the problem is if I start putting numbers in, I'm going to get these really small values for y. So I'm going to wind up somewhere over here, and it's just hard to graph. And the other thing is it's only as exact as you draw the graph. So unless you're using a program like Desmos or something where it does it for you, you really need to draw like an immaculate graph in order for everything to work out perfectly. So the way we counteract that is we solve these things algebraically. And it's exact, and it's efficient, and it's quick, and it's everything we want it to be. So when you solve these algebraically, basically all you're doing is you're making the recognition that, and I'm not saying this one looks like this, but you're making the recognition that wherever this thing crosses the y-axis, that's your zero, all right? That's the zero of your function. So we know that at that point, y is equal to 0. So we're going to use that. We're going to use that information to solve this equation. And all we got to do is get rid of one variable. And once we get rid of one variable, there's only one variable to solve for, and you guys know how to do that. So what we're going to do is we're going to recognize that this is, we can rewrite this, right, as y equals negative 16 minus 2x. And then we just said that if we're looking for a zero of a function, we know that y has to equal 0. So what I'm going to do is I'm going to make y equal to 0. I'm going to go minus 16 minus 2x. Now at this point it just becomes a multi-step problem to solve. All right, so look at this. We know that we want to get this negative 2x by itself, so we're going to add 16 to both sides because it's the opposite of what it is right now. This cancels out over here and you get negative 2x over here, and then you get 16 right here. So then the next thing I'm going to do is I want to get x by itself, and you get x by itself by dividing by whatever the coefficient is. So it's negative 2, divide by negative 2, and then you do the same thing with the other side, and then these should cancel out, and you should get x is equal to negative 8. So if I did this right, I can take this number and I can put it back in here, and it should work out. All right, so let's do that really quick. So I want this side to be 0, and then I'm going to go negative 16 minus 2 times negative 8. Well, 2 times negative 8 gives me negative 16, right? And it's negative 2 times negative 8, so that actually makes it positive. So you have negative 16 plus 16, because you're multiplying this and this. And negative 16 and 16 are additive inverses of each other, and they cancel each other out. And so you get 0 equals 0, which is an equality, and that's what we want. So we're in good shape. All right, so the 0 of this function is x equals negative 8. Let's box it and call it good. All right, let's look at a couple other examples here that I have written down. We have f of x equals 15 plus 6x. So let's, in our heads, let's reimagine this as y equals 15 plus 6x. And we know that when y is 0, that's where the 0 of the function is going to be. So I'm going to set y equal to 0. And then I'm going to write the rest of this out and solve for x. So I've got 15 plus 6x on one side. So I'm going to subtract 15 from both sides. Sorry, my pen is being super glitchy lately. I don't know if my iPad is messed up or something, but it's kind of annoying. So we have negative 15 is equal to 6x. All right, and so now I am going to divide both sides by 6. All right, that gives me x over here. And then negative 15 divided by 6. If I simplify that by dividing them both by 3, I get negative 5/2. And so negative 5/2 should be the point at where this goes through the x-axis. All right, so let's test that by putting that number back in the equation. So we have 0 is equal to 15 plus 6 times negative 5/2. All right, well, 6 times negative 5 is negative 30 over 2. So you have 15 plus negative 30 over 2. Well, 30 divided by 2 is 15. And then that's going to be negative because of this sign right there. So 15 minus 15, and that's 0. And that works out. Okay, one last example for you. And if you want to ever try any of these before I do it, go for it. So why don't you pause the video if you're watching this and learning from this. Pause the video and see if you can solve this. Okay, let's do what we do and set this side equal to 0. And then you have 1/2 plus 2/3 equals x. This one's a little trickier because of the fractions, but it's the same process. You're going to try to get 2/3 x by itself. So we're going to subtract 1/2 from both sides. And that leaves you with 2/3 x, if it will let me actually write it down. And then you have negative 1/2 over here. Then remember, to get rid of a fractional coefficient, you always just multiply by the reciprocal of that. So it's 2/3. The reciprocal of 2/3 is 3/2. So I'm going to multiply both sides by 3/2. And then I will get x, because all this stuff cancels neatly. I'll get x equals negative. 3 times 1 is 3. 2 times 2, 2 times 2 is 4. So you get negative 3/4. That is simplified. Let's just plug it in really quick, see if it works out. So 0 equals 1/2 plus 2/3 times negative 3/4. Well, your 3's cancel, and then you have negative 2/4, which is negative 1/2. So you have negative 1/2. Half minus a half gives you 0, and we are good. Check. You have done this. So this is the process of how you find a 0 with linear functions. So you should be able to go from here and try some of these problems out and hopefully be successful.